So in this video, we are going to start a discussion on new chapter, and the name of the chapter is called circles. So as we have seen multiple times in the past, that circle is a very important geometrical figure, and we have lot of properties surrounding this geometrical figure, and those properties are really interesting. Lot of interesting theorems around them, and they are used to solve many exercise problems. It's a very important chapter. We also have this chapter or this concept of circles in the next standard, which is standard 10th. So this chapter is going to be like a foundational chapter, which will help you to solve a lot of problems even for standard 10. So let's begin the discussions on this interesting geometrical figure called as circles. So let's start with the point number one. What does point number one say? It says how to construct a circle. So we begin our discussion with a very simple task, and the task is to find out how to construct or how to draw this geometrical figure called as circle. So here we have an interesting geometrical instrument which we all must have seen. Okay, it's called as a compass. So here you put your pencil, okay, and this is the point of the compass. So typically what we do is we fix this point, okay, on a piece of paper, and we just rotate this pencil arm of the compass, and we get a circle on a piece of paper. So that is how you exactly construct a circle. So I'm going to construct a circle here, okay, using my, not by using compass, but by using this pencil. So this is how the circle will come, okay, once you draw it on a piece of paper using this compass. Now the important thing is this point, okay, this point which we fix on the circle on the piece of paper will be this point, okay, this point, and it is typically called the center of a circle. So I'm going to name the center of circle as a point O, okay, and then we have this. Now from the center of a circle we can draw a line, okay, this is the center of the circle. You can draw a line to the end point of a circle like this, okay, like this, like this. Just keep on drawing different lines from the center of the circle to the end point of the circle, okay. So if this point is called the center of the circle, then these line segments, all these line segments are called as the radius of the circle, okay, and that is what is the second point in our discussion. So I'm going to remove this. Oh, I think I have missed the definition of a circle, and I directly jumped to the center of the circle. Okay, no problem. So before we discuss the center and the radius of the circle, let's quickly go through the formal definition or the mathematical definition of a circle, which reads this. So I'm going to just put it aside. Okay. So the collection, let's try to, yeah. Now, the collection of all the points in a plane which are at a fixed distance from a fixed point. So I'm going to highlight this. These are very keywords. Fixed distance from a fixed point. It's called as a circle. Okay. So what is circle? It's a collection of all the points. So let me use a different highlighter here. Collection of all the points. So these are those points. Okay. Collection of all the points. And what is the characteristics of all these points? They are at a fixed distance from a fixed point. So which is the fixed point? So let's use a green. Yes. So this is my fixed point, and this is my fixed distance that I was talking about. Okay. So what is a circle? Circle is a collection of all these pink color points. Okay. And what is the characteristic of all these pink color points? They're at a fixed distance from a fixed point. Okay. Now this fixed point, which is at the center, is actually called the center of a circle. So I'm just going to draw an arrow. This is called as the center of the circle, and this fixed distance is called as the radius of the circle. Radius of the circle. Okay. So we have understood what is the definition of a circle. Okay. We know how to construct a circle. We know what is the mathematical definition of circle, and we know these two important terms: center of a circle and the radius of a circle. So that is what is, I think, point number 3. Let me remove this. Yes, center of a circle and the radius of a circle. Now just to make the point clear, I'm just going to draw a circle here. Okay, and I'm just going to mark the center. So this will be called as the center. Let me call it O. Okay, and this is the radius. Okay, and as we saw before, there are infinite number of radiuses possible through the center of the circle. Okay, so let's name them. So let's say this will be P, Q, R, S, T. Okay. So what are the radius? So in this figure, the center of the circle is O. So I'm just going to make the center of the circle is O. And what is the radius of the circle? The radius of the circle is OP. Okay. OQ, OR, OS, OT. These are all the radius of the circles. These are line segments, okay, which all are of equal length. So till now we have seen some very basic and very crucial terms that are related to the geometrical figure called as circle. Now let's go to point number 4. What is point number 4? Chord of a circle. Now this is another important definition or a term related to the circle. What exactly is a chord of a circle? So take any 2 points P and Q on the circle. Then the line segment PQ is called the chord of the circle. Quite simple and straightforward definition. Now I am trying to delete this. Yes. So let me place it here, and okay, let's move a bit here so that I get space. So let's once again draw a circle to understand this concept. So I'm going to draw a small circle here. So this is the circle. Okay. Now let's read what the statement says. The statement says, take any 2 points P and Q on the circle. So I'm randomly going to take any 2 points on the circle. So let's say this is point number, okay, this is point P and this is my point Q. And then it says, then the line segment, okay, then the line segment PQ is called the chord of the circle. Quite simple and straightforward definition. All you have to do is connect these 2 points P and Q, okay, with a line, and this line segment is called as a chord of the circle. So I'm just going to make like this. Okay, this is called as a chord of the circle. Quite a simple definition, right? Take any 2 points, connect them through a line segment, and that line segment will be called as a chord of the circle. Now, within the chord of the circle, we have an important type of a chord, and that is called as, here it is, that is called as a diameter of the circle. Now what is the diameter of the circle? A chord that passes through the center of the circle is called as a diameter of the circle. Okay, I'm just going to place this aside. Okay, so what is the diameter of a circle? It's a chord that passes through the center of the circle. Now if you notice the chord that we constructed here, this chord, this, does it pass through the center of the circle? No, the center of the circle will be somewhere here. Okay, the center of the circle will be somewhere here. So this chord obviously doesn't pass through the center of the circle. But if I construct a chord which intentionally passes through the center of the circle, which is what I'm going to do now. So let us first draw a circle here. Okay, let this be the center of the circle. Now I will draw a chord which will pass through the center of the circle. So something like this. Then this chord will be called as the diameter of the circle. Now, how many diameters a circle can have? It can have infinite number of diameters, because this is also, okay, because this is also a chord which passes through the center of the circle. This is also a chord which passes through the center of the circle. This is also a chord which passes through the center of the circle. I can keep on drawing infinite number of such chords which pass through the center of the circle. So that is our next point under this, that how many, okay, how many diameters a circle can have, and the answer to this question is infinite. A circle can have infinite number of diameters, which is a chord that passes through the center of the circle. Now the last point here is, in this part 1 of the video, is, let's try to remove this, length of the diameter. Now there is a relation between the length of the diameter and the radius of the circle. So first of all, just to quickly bring it in the context, once again let me draw a circle here. So this is a circle, okay, and this is the center, or okay, this is the center of the circle, okay. Now, what is the diameter? What is the diameter? It's a chord that passes through the center of the circle. So I'm going to draw like this. It's a chord that passes through the center of the circle, okay. And what is the radius? What is the definition of radius that we saw before? Radius is any line segment that connects the center to the end of the circle, okay. Take this center and connect it to the end of the circle. So this part, so let's call this O, okay, let's call this point as P, let's call this point as Q, okay. So is OQ, so okay, let's write it. OQ is equal to radius of the circle, yes, and OP is also radius of the circle, yes, and PQ is the diameter of the circle as per the definition. So we can clearly see that this diameter, whole diameter PQ, consists of these two equal radiuses. Okay. Why so? Because the radius, because the length of all the radius of a circle is going to be the same. Why? Because that is the definition of the radius. Let's go here. Yes. Fixed distance. What is a radius? Radius is something which has a fixed distance from the fixed point. So all these radius are at the same distance from the center. So the length of radius of all the circle is exactly the same. So length of OP in this figure, OP and OQ are equal to each other. So I want to just write it here. But OP is equal to OQ, and therefore PQ will be equal to 2 times the radius of the circle. Okay. So this 2 is an important, I'm going to highlight it. This 2 is an important number which gives us the relation between the diameter of the circle and the radius of the circle. Every diameter of the circle will be twice the radius of the circle.